So Jim, what are we going to talk about today?
Multivariate analysis.
Okay, so for all of us that aren't, data nerds and just normal geniuses, can you tell the rest of the world what multivariate analysis is so we can save about 50,000 people from going to Google?
I chuckle because I'm hardly a genius. Fortunately, this stuff makes me look really good. So multivariate analysis is a lot of the algorithms that happen to be in it, which the ones that typically you'll see are principal component analysis, or PCA, partial least squares, or PLS. Let's see, there's probably one other one, but those are two of the main algorithms you'll see. They're kind of grouped in that machine learning, bucket, right? They're like a little section of machine learning. There's a whole bunch of other algorithms out there. But multivariate analysis, that's easy for me to say, really is kind of geared, I think, really well at the process industries. It seems to find relationships, especially in kind of linear processes. And really what it does, I mean, if you look at that screen, each one of those dots represents basically a product genealogy. It's a batch in one process, a batch in another process, and then some continuous data, all that one particular starting batch went through, right? Through several hours worth of things. Summed up mathematically in a three-dimensional space. It's a dot. So if you think about it, if I sum up mathematically all the data in one batch run, I'll have a dot somewhere in space. If I run really close to the same, I'll have another dot pretty close to it, but not exactly on it. If I run very differently, that dot's going to be very far away. There's going to be something mathematically that drives it, in an opposite direction. And so with that, then you can start to understand, well, what are those variables that drive it away? And you can even classify things like, hey, maybe this was a good run, this wasn't a good run. And so you can really kind of understand your process. And what I always tell people, you can eliminate ground. You can throw a bunch of variables at it, ask some very specific questions. Don't think you're just going to go, oh, I'm just going to throw a bunch of stuff against the wall and just, this is going to tell me everything that I've ever done wrong in my process. That's not the way this works. And it's not a silver bullet, but it helps you eliminate ground, and it really tells you, well, what's different? What changed over time, or what's different between this batch and that batch that I ran, and this one's good, this one wasn't. What was different? And where it's not obvious.
Okay. So we've got a bunch of data. We want to run it through a system to understand how all of these processes and procedures change for the outcome that we have. No, perfect. And then I know you said that for this application, what we're talking about is on SIMCA. Is that the favored? Is that the favored tool for Industrial Insight? Is that one of the tools? Is this the best tool out there?
Well, it's what we learned on. I think it has the best interface, and I think certainly the orthogonal piece seems to work very well. I've talked to, there's a gentleman I'm good friends with who works for one of our customers who's been, he's a, master's degree level statistician, 30 years in the business, and this is all he does, and he evaluated everything. And he said, this is the best tool for us. And, he told me why. He loves the orthogonal component. He feels like it gives him a bit more accuracy. I'm not a statistician. I'm not a math genius. I don't necessarily understand all the mathematics behind it, but are there other products? Yeah, I mean, we've got a customer also testing out Aspen's Pro MB. It's got the same algorithms, just without the orthogonal component. The user interface is slightly different, but it essentially does the same thing. PCA is PCA, PLS is PLS. I mean, that math's been around for a long time. And really, it's about the user interface, the support you get with the product, and, in their case, they have an additional algorithm that, people in industry who seem to know, really like. So for us, Yeah, it's our go-to tool. We know the SIMCA folks well. We think they're very sharp. They've been incredibly, gracious to us with, letting us use the software, and for that, I like to show it off when we get a good story, and that's why you're here today, is
Yep.
because I think we have a pretty cool story that we're gonna talk about.